Okay. So I hope you guys here already submit the homework. And I plan to discuss about the homework today, but maybe first of all, maybe some of you haven't joined the TA class last week. So maybe just for refreshment and also for the attendance, I will show the PPT here. Wait. Mm, So where's present? Oh yeah, okay. Mm, mm, okay. Okay. So just for refreshment, maybe some of you haven't joined the class from last week. So I will call of us like the Calculus crewmates. It's inspired by one of the game in the online thing. It's appeared during this COVID-19. It's quite interesting image though. Don't forget when you learn, teach, and when you get, give. And this is our value in this class, and I hope you can use it for the entire life. First, honesty, be honest for yourself and your capacity. If you cannot, just say that you cannot, and let's learn together. And if you can, don't hide it and use it for good for other people. And don't forget to learn and share, because in the college here, in education and study, not only in calculus but for everything, the most important thing is we can learn and we can share with each other. Oh, thing you cannot see here, right? Yeah, I think it's okay. This one. Yeah. And this one is for the attendance today. Maybe I give you guys 5 minutes or maybe just 2 minutes for fill the attendance, and we can go enter the class afterwards. No, there's no. Thank you. So there's almost no problem with the class so far, right? Good, good, good. So that's easy money. Fitting the graph. So far, 16, 15, 16 students already. Continuity. No question, no problem so far. So good. But I prefer more homeworks. Oh, one student prefer more homeworks. Eh? Okay. Good, 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 good. Maybe maybe I'll tell Professor Iwan later. Good, good, good. Good excitement. 19 students so far, 6 remaining. Okay, maybe during our waiting for the 5 remain 6. Yeah, 5 to 6 remaining student. Can anybody in this class review at least what is the last class that you have learned with Professor Iman? Maybe until today. Anyone that can review what that you have learned until today? And I believe, uh, I don't know, is it already uploaded in the Moodle or not? That Professor Iman already give like additional online class, and you guys maybe can check it in YouTube. Anyone? Oh, okay. Maybe I learned from last week. Maybe I can try to choose one of you to answer. I hope it's not really pressuring too much for you, right? But let's try, let's try, let's try. Let's just try to share what you got during the class. Maybe I want to start with. So can we discuss some number of the homework? Sure, 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 sure. After this, we can discuss our homework. And but first, I would like to hear it, and maybe we can learn together what 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 you guys have done in the class. Maybe I would like to ask Evando Gunawan. Are you there?
Yes.
Okay, okay, thank you. Can you share to us what what we've
Well,
learned in the class from Professor Aim?
today
Hmm.
we learn quiz, quiz theory and continuity.
The what and continuity?
Squeeze, squish.
Oh, squeeze and continuity. So today class, you guys learn about squeezing and continuity.
Yeah,
Ah,
and
okay. Hmm.
horizontal asymptote.
Horizontal asymptote. Okay, 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 okay. Good one, good. Thank you, Evando. Maybe any other, or are you guys already see the additional online class from Professor Iman? Because there's something. Oh yeah. If you guys don't know, maybe I can show you one example. Hmm. So you guys can check here. This is the YouTube channel from our professor, and in here, I think there's some additional online class that you can learn here. Maybe Professor Iman already explained it, but you can study here since we need to squeeze all the schedule here, so you can learn by yourself from watching YouTube. It's quite good, though. So you don't need to attend the class. Okay, so today I would like to discuss about the homework that me and other TA give you guys. Is there any problem with the homework? I've seen actually it's pretty much good. None. Yeah, it's quite easy money, right? But maybe some we can discuss since there's a little bit not quite different answer, but we can we let's just take a look at the homework. Okay. Mm, so let me present. So this is the homework. Actually, it's just reviewing from the domain and determine what is even, odd, or neither. Explain what it means to say blah 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 and all of this. And it's already 23 students, I think, that already submit the homework. But there's some interesting answer that maybe I would like to discuss. Maybe I just can put randomly. It's okay, right? Mm, okay, maybe start from here. B11035. Sorry, I'm not really good at Chinese, so maybe I just mention your student ID number. So this one is from B1103526, Jonathan Albert. Okay, maybe it's is it okay if we discuss the homework one by one, even if it's easy, but at least we can make sure that everyone can understand about the homework. So later maybe I will put no, I will take random homework, and I would like to hear from you guys how you explain the homework as best as you can. It's okay, and let's see if any other student have the respond for the homework. So let's start with number one. It's to find the domain. Maybe Jonathan, can you explain how you got your result? Why the result is x not equal to -3 and 3? Jonathan?
Yeah,
Okay.
because the uh, what do you call the
Denominator.
yeah, it cannot be zero, right?
Yep. Mm-hmm.
Yeah, that's why the domain cannot be -3 or 3 because it will make the dominant zero.
Okay. 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 Very good. Thank you, Jonathan. So the basic is very simple. The domain itself, it's how what number of x that you can put in the function that make sure that the function can work. Because Professor Iman before already explained to you that the function is like the machine, right? And you put the input and the machine work and you get the output. But you have to make sure that what input, which is the domain that you can enter to your machine. And from this function, uh, it's pretty simple. I believe you already learned about factorization in the high school, and you got the result. And it's pretty simple. Like x must be a real number, and it's not like -3 or 3. However, maybe we can put like in the mathematical language. Is any other student want to explain or make a comment with the answer? The answer is true though, but how we put it in the mathematical language? Is anyone? Maybe I will put. I will take one example because some of you guys got the answer right. Oh yeah, maybe Evando Maria Gunawan. Yeah, there's one mathematical language. Can you explain why you put your answer like this? Yeah, we know from what Jonathan told us, like x -3 and 3 is not good. But why you put like that? Please,
Uh,
Evanda.
well, because it's every number except that, so from negative infinite until infinite.
Hmm, hmm, hmm. And why you need to put like -3 and 3 as well in the middle?
It's until because there's the middle of -3 and 3 also. Not
Okay, okay. Thank you very much, Amanda. By the way, guys, if you uncomfortable to explain in oral, like speaking, it's okay if you want to type in the message in the Google Meeting. Yeah. So, like what Evando say, the number that we can put is basically from the minus infinity until before -3. So we can put like -3.0001, and we can also put like the number between -3 and 3 and the number after 3. So this like from what Jonathan give us, it's true that we can put the x equal -3 and x equal 3. It's true. But how we can explain it in mathematical language, because math, calculus, everything is, it's still a language, but it's not with alphabet, but it's with numbers. So this is how you explain the domain, what is. And maybe one important thing, Evando here use circle bracket, right? Maybe you guys will see the square bracket. Is it anyone understand what's the difference between square bracket and circle bracket or round bracket? I'm sorry. Anyone can explain, share to the class what's the difference between.
Well, I can explain the difference. When we use the parentheses for the interval notation, it means that the number is not included for
Mhm.
the domain.
Mhm.
However, if we use the brackets or the square brackets for the interval notation, it means that the number is included in the domain. So, for example, if we use a square bracket at the right of -3 instead of a parentheses, it means that -3 is part of the domain. But in that case, it's not. So we use the parentheses to signal that it will only be until -3, but not including -3.
Okay, okay. Thank you, Rion. So it's true. If you use like parentheses with the round bracket one, you didn't include the number in it. This one. But if you use the square bracket here, you need to include the -3 also. Yeah, it's pretty simple explanation. So there's the explanation for number one. Some of you guys, I see that like this. It's true, but it's not yet complete. But it's true. You can use like minus from minus, but don't forget you can still use the number between the -3 and 3. And all the other example, I believe you also understand what you have written. So later on, don't forget to make sure that you can uh, put the answer in the mathematical language. Okay. So any problem with number one? I think no, right? Because it, I've seen all of you guys have answered correctly, not -3 and 3. So I think we can continue for number two. So whether f is even, odd, or neither. Okay. So we want to explain either if the f is even, or if the function is even, odd, or another. Okay. Maybe I would like to ask the student B110311046. Is he come today? Let's see. 110146. think your English name is Chio. Chio, are you here? You're not comfortable with speaking. It's okay if you type. Yeah. Thank you. Thank you. Thank you. Thank you. Can you explain your answer from number 2? Why you said that the result is odd? It's quite interesting though because you use the table. Maybe you can share. Or maybe you can type in Chinese. I will try to translate it using the Google Translate. But it's okay. If you want to talk, it's okay. Chiu. I will give you time if you type. Or maybe you can say okay.
Can I speak Chinese?
I don't really understand in Chinese, I'm sorry. Maybe you can type it in Chinese, is okay. I'll try to translate it into English. But try to use English then. Like why it's odd function.
所以我可以讲中文吗？
Okay.
Let me think.
Mhm. In this number, I've got pretty interesting answer. Some of you said it neither, some of you say odd.
I use graph is only to make a example. And the conclusion f of x is when you put x in the f of x is
Here, right? You put minus x here.
and if you put negative it is negative, so f is odd.
Okay, very good. Thank you, Joe. So this quite a good example for proving, right? Like if you put the +1, the -1. So basically, for just reminder, the odd and even is like if you put the negative for the x, how's the function work? If it's work the same, then it's even. If it's work as the negative side of it, it's odd. And if doesn't work either way, it's neither. It's as simple as that. But from what I see from Joe here, you can see if you put minus x here and you put in the function, the x will be minus x, right? And the minus x, you put the x squared here, minus x squared will be still x squared plus 1, and only the minus x here. So you move the minus here, and then you got that the function is minus the function before. So that's why it called odd function. But pretty good example because Joe here used the, like for proving. Later on, maybe in your study, when you already enter the specific, like maybe civil or chemical, material, or mechanical, proving is very important because we always work with empirical. As engineer, we always use the empirical one. So this one is very, very good example. Like if you put 1, you got half. If you put -1, you get minus half, and so on and so on and so on. That's pretty good, Joe. And some of you guys also has the same answer, the odd. Some of you maybe got, I think, some of you got neither, because maybe you have to be careful when you put the minus x to the x square. So you need to square the minus x, not minus x squared. No. So I think there's no problem. Is there any question maybe for number 2? Because number 2 is one of the example that it's pretty balanced answer. Some of you answer neither. Some of you answer odd. But then got no answer even. Okay. Maybe there's no problem. Okay. Thank you. Thank you for sharing your answer, guys. So we can continue. For number 3, explain what it means to say that limit x from the left side of x equals 1 is 3, and from the right side is 7. In this situation, is it possible that limit f(x) exists? Explain. Okay. I'll try to... I want to choose guys that only answer. But I think it's pretty simple, right? Oh, you guys very good. Yeah, you really explain it. I think number 3 is easy money, right? Because all of you already explained it. Don't forget, guys, if you answer your homework, I believe Professor Iman already said it. Professor Iman and I also other teacher, I believe we really appreciate the process. So maybe your answer it's not correct eventually, but your process is correct. It's already good. So don't forget to explain as best as you can. But I think from number 3, it's quite easy, right? In this situation, is it possible that limit x to 1 fx exists? No, because if you take from the right side is 7, and if you take from the left side is 3. So basically, how it exists, it approach from either left or right, it has the same number. So it's easy money. Okay. Now, no question, right? From number 2, it's pretty easy. Now for number 4. Another explanation. Maybe I want to ask number 4. Okay. Who's this guy? B10905013. Who's this guy? Let me check the English name, or you can explain the. You can speak the. Winston. I believe it's Winston. Winston, true?
Hi.
Hello, Winston. Yeah, this is your homework, right?
Yes.
Okay. Can you explain your answer why you got A4, A5, or maybe I will help you to show you the figure. You still remember your answer, right?
I don't know how to explain.
You don't know, or you want to explain it? Type it. Like, okay, what's your homework? Hey, wait, what is it? This one. Why you say that A4 for the first one? It's French. The A equals 4. Limit gx does not exist, but ga is divine. And you say 4. Can you explain why? If it's hard, it's okay if you want to type it. Or you want to type it in Chinese, it's okay. I will try to.
My English is not really good.
It's okay, it's okay. Try your best, try your best. At least we didn't grade your English, so it's okay. It's okay. You said that gx x does not exist. So x to 4, it's not exist, right? You say it,
Yes.
but function g4 is defined.
Yes, because the uh, the
Check it, check.
limit
Hmm?
left
From what?
for
If you take from left,
from left
Mm.
the number
in here,
is yes,
in the bottom. But if you take from the right,
right, yeah, it is the
different.
not the that not that is different.
Ah, yeah, yeah. So if you take from the right, and if you take from the left, it's different number. So
Yes,
it's not exist. But G4 is defined. How come?
because the
There's a point here.
yes.
Ah, okay, okay, okay. Okay, good, good, good. So why GX does not exist? Like why what we learned from number 3? From left, we got certain number. From right, we got certain number, but it's different, so it does not exist. But Vincent said that the G4 is defined because there's a point here. There's not gap like this, like this, like this, like this, but there's a point here, which means there's a output to y when you put x equal 4. But if you talk with limit language, it does not exist. Okay, very good, Vincent. You want to try your explanation for the B1? Let's say, what's your answer? A equals 5. Limit gx exists, but ga is not defined. Ah, yeah, yeah. Can you explain, Vincent? For the B?
Yes, yes.
Mm-hmm.
Because the when a
Mm-hmm.
is 5, my answer is a equal 5,
Yeah, yeah, true, true. Why?
and from the left is the left limit is equal the right limit,
Yeah, this one.
and
Mhm.
there is no no no
No gap, gap.
no gap.
Yeah, like
So
this one, right? Like the 4 one.
yes,
Uh-huh.
and
So from left and from right, you got the same point.
yes,
So it exists. But why G5 is not defined?
because there is no blank.
Ah, yeah. There's no like this, right?
Yeah, yeah.
Yeah, yeah. So there's a gap. If you, what Professor Iman say, if you zoom, 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 the graph, it's a small gap in that exact number. But if you talk about the limit language again, it exists because when you approach the 5 and you approach the 5 from the left and you approach the 5 from the right, you got the result. But if you define at that exact point, there's no point in here, which is this is blank one, right? Okay, the C1 limit gx and gx from the left and gx from the right both exist, but limit gx does not exist. It's 2 and 4. Winston say it's 2 and 4. It's pretty easy because like what Winston say before, uh, G2 and 4. Yeah, gx from the left and limit x from g both exist, but limit gx does not exist. So 2 and 4, we can see that from the left we got one number, and from the right we got one number, and also with 4, from the left we got one number, and from the right we got one number. But because there's a gap here, which means that the function from with x equal 4, there's a gap here, it's not the same. So basically, the limit does not exist. And from the D1, the answer is 4. Limit gx, it's from the right, it's equal to GA. But limit GX not equal to G, because from the left, it's not equal with 4. But if we take it from the right, it's equal 4. So it's pretty easy. Thank you, Vincent. Thank you. It's pretty good, pretty good. One good failure is you're very brave to explain it. Very good, very good. Okay, no problem, right? With number 4, it's pretty easy. Now we talk about evaluate the limit if it exists. Pretty much from number 5 to number 10. Number 5 first. I think all of you guys already answered correctly. Let's see. Number 5, yeah, very good, because you guys already used the limit low. So basically, if you put plus or minus inside the function, you can separate between those and put the limit for each and just input all the x. So maybe I'll take one example. B1 110 31 024. It's pretty easy, so maybe I will not ask you, but I will just explain briefly. In here, it's true. Like limit x approach 5, and you just input it. You got the number 100, and you just put it and got 25, and the result is 75. Everything just pretty easy. But don't forget, if you want to check if the limit exists or not, make sure that maybe you can try to separate the limit. So don't just put 5 here directly to here, but try to separate limit for x squared minus limit x5 approach 5x. Again, this is how the language of math. So it's pretty easy because you just input the number, but don't forget the process. The process itself is very important. Yeah, like this. This is quite good process. You can separate first, follow the limit low, and then input 5 inside, and everything just easy money. But don't forget to make sure to separate it first. So we can define that if the function x squared exists, the function fx exists, and then you can directly put the number. So it's pretty easy. And number 6, it's also pretty simple, right? Because there's no 0, you just can input x equal 3, cube root 8 and equals 2, you put 3 to here, 9, 18, minus 9, 9 times 2, it's 18. So pretty easy money. And the next one, okay, number 7. Maybe I want to ask, yeah, it's quite a good answer. Okay, who's this one? 031038. See, hey, I already asked this person before. Oh, maybe the other one. 7. I already asked. 7, 7. Oh, it's quite interesting answer. Okay. 109 109 05114. Who's this guy? 109. Are you come to the class? Oh, okay. Mak How Wai. Do I pronounce your name correctly? Yeah, Mak How Wai. Okay. Can you explain your answer? I believe there's some part is missing here, right? Maybe you want to explain? Oh yeah, you're typing. It's okay, it's okay. How you got the result is 3/7. So basically x squared plus 3x divided that. The factorization, the bottom one you got there. And how come you got the third line is there? Yes, 7. 3/7. Yeah. If you see the until the second row, it's already good, right? X squared plus 3x. You factorization the bottom one, the denominator, x minus 4 and x plus 3. And how come you got the x over x minus 4, the third line? This one. From here
I
to here.
the number 7. I spare off the I don't know how to say that.
You separate this numerator, right?
No,
Numerator.
the next part.
This part. The upper part, right?
No. The below of that.
Oh, you put the x outside.
Yes.
X times
And
x
so
plus
I
3.
can and take off the
Okay.
x plus 3.
Okay. So you put x outside, x times x plus 3, right?
Yes.
Okay. And you got this, you put the number inside, and easy money. Okay. This is a correct answer, but don't forget, don't miss the process here, because from here you need to explain how you come to here. But it's correct answer. But just don't forget to make the process as a whole. So write first between this one, x times x plus 3 divided by x minus 4 times x plus 3. And then scratch, you get this one. But it's good. It's good. Thank you. Thank you, Makawa. Pretty simple answer. Okay. Easy money. No question, right? For number 7. All of you, I believe it's true. Number 8. Number 8. Let's see. I'm pretty interesting with some student. Waiting is very good. Oh, here. Let's see your number 8. Okay, Ria, can you explain your process?
Hello. So for number 8,
Mm-hmm.
we can if we substitute number 9 or the value 9 directly to the limit, we get that the value will be that the result will be indeterminate, meaning that the numerator and the denominator will both be equal to 0. So in order to prevent that from happening, we modify the limit a little bit by using the conjugate of the denominator, which is 3 plus square root of x. We multiply that to both the numerator and the denominator, and by doing so, we get that the numerator is equal to 9 minus x times the quantity of 3 plus square root of x. Then for the denominator, it is in the form of x minus y times x plus y, so which is simply x minus y squared. Sorry, x squared minus y squared. So 3 squared is equal to 9 minus square root of x squared is equal to x. Then so we get that the denominator is 9 minus x. Also, we can see that that 9 minus x is present in both the numerator and the denominator, so we can just simply cancel that out. So to get the result of the limit of 3 plus square root of x as x approaches 9 is equal to, oh yeah, so we get the following limit. Then we can just solve it through substitution. So 3 plus square root of, so we will get 3 plus square root of 9. Then square root of 9 is equal to 3. So it's 3 plus 3. Then 3 plus 3 is equal to 6. Therefore, the limit of 9 minus x all over 3 minus square root of x as x approaches 9 is equal to 6.
Okay. Thank you, Ren. Thank you for sharing. So basically, that's the process. If you have like the square equation here, you can use like what Rian say, conjugate, because this is minus. Try use the plus here. So when you times the denominator here, the numerator here, and here, you got 9 minus x, because square root will kill each other, right? So it's x, and 3 times 3, it's 9. And you just can erase these two, and you got only this function. And you got all the result. Just for a reminder for all of you guys, if you want to evaluate the limit function, don't forget that if this function is fx, it doesn't mean that this 6 is the result of fx, because you need still to put this one to here. So it's like different function. I believe Professor Iman already told you that it's not necessary the function of fx, because the function of fx at first is like this. But it's how you to determine when the denominator is 0. So that, just quick reminder. So every of you already put a good result. And maybe I will make it fast for 9 and 10, because I think it's already finished, right? Yeah. For 9 and 10, explain why. Maybe I will make it quick. Maybe I will use other one homework. This one is very good. If it is 8 does not exceed y, the limit for number 9 is y it's not exist, because if you put from the left one, it's go all the way down for number 9. But if you got from the right one, I think there's no graph here, but the graph will be go to 0. So if this function approach from the right hand side, it will go to 0. But I think it's not the correct graph. I will show you later what is the correct letter. But pretty much all of you already explained correctly why from the left hand side is not exist and from the right hand side is exist, which is 0. That's pretty good. So next time I will grade your homework, and I will put the grade in the Moodle. Just check the Moodle letter, and for the infinite.tne. Wait. Oh yeah. Okay. Thank you. Because the letter does not, if the limit does not exist. Oh yeah. Okay. Thank you, Rian. Yeah. It's go to the minus infinity, because if you take from the left hand side, the If you approach 0, it will be infinity, but from the right hand side, it will close to 0. Maybe next week I will explain more detail with this graph, because this graph is only 1 over x, not 1 over absolute x. Okay, maybe later. Sorry, because the time is already up. Maybe I will put the explanation next week. But I hope that today you already find the clearance for all the answer. One quick question: do you have any homework from Professor Iman? Anyone? Do you have any homework from Professor Iman from today or before? Oh, okay. Thank God, though. I will see. Maybe I will discuss later if I think we should have the homework again or not. But pretty much all of you already answered it very good. Don't forget the process. Don't skip the process and write everything orderly. And Ryan, please remind me next week for number 9 and 10. I'm sorry, maybe I take too much time, but I will explain better the number 9 and number 10 with the graph. I will use the geograph later next week. And let's see if we can discuss anything from Professor Iman class or maybe from the homework. Just make sure you pay attention to the Moodle. Okay, any question? Is any of you already filled attendance? Maybe I will share once more. The attendance. Maybe if any of you haven't filled it. So, okay, I think today is up. You can leave the class, and I want to say thank you. So, learn for today. Don't skip the process, and just be brave. Thank you for explaining the answer too. Good, very good. Thank you, class. See you next week.